Good morning, good evening, or good afternoon, depending on where you're joining us from today. We would like to welcome you to today's session of the Azure webinar series. Our topic today is Monitor and Troubleshoot Your Networks Using Azure Solutions. Before we get started, I'd like to go over a bit of housekeeping. You do have a Q&A window, a box on your webinar console, and that's on the top left corner. If you have questions during the webcast, please pop those in there. We do have subject matter experts with us today who will stay with us in real time answering those questions as they come in. You will also get a copy of this presentation after the webinar. Keep an eye on your email. You'll see that there within about 48 hours. On the top right-hand corner of your console, you're going to find a resources widget. And any URLs or useful tools we might mention today will be easily accessible for you there. And finally, on the bottom right-hand corner, you're going to find a survey. We're hoping to get some feedback from you about today's session and maybe give us some feedback on what you would like to learn more about related to today's topic. All right, we have 4 speakers with us today, and I'm going to hand it over to AJ. AJ?
Welcome. Welcome to today's session on network monitoring and troubleshooting in Azure. This session is going to be relevant to you if you have a network that is connecting more than a handful of VMs. If you have a network that has multiple applications and services that are dispersed across multiple regions, possibly multiple subscriptions, or you have a network with a large number of networking components, load balancers, app gateways, and the like, whether these networking services are provided by Azure or you have downloaded them from the Azure Marketplace. In today's session, we will cover how you can monitor such a network, and should an issue arise, how you can service heal the network, how you can fix the issue and get up and running quickly. I am Ajay Gumadi. I am from the networking team in Azure. I will be followed by Abhishek. Abhishek will talk to us about a single health console from where you can see the health of your entire network. That's across your subscriptions, across your regions, and across your resources. Dylan will share with us tools to run diagnostics, to run troubleshooting across various resources such as VPN gateways, custom routes, NVAs, etc. And finally, Vinny will show us how we can monitor such a network and how you can audit this particular network, this network in the cloud. You may be aware of some of the solutions that we work on. So we work on Azure Monitor, Network Watcher, which is the primary solution for monitoring networks in Azure, for monitoring troubleshooting solution in Azure, Network Performance Monitor for monitoring connectivity to applications and networks within and across data centers and clouds, and Traffic Analytics, a solution for auditing user and applications network activity in the cloud. Starting with Azure Monitor. As a user in Azure, whenever you use an IaaS service such as a VM or a PaaS service such as a SQL Server, all of components that we ship send telemetry, health information, and observability telemetry into Azure Monitor. The data is constantly refreshed and is usually no older than a minute. The data points that are there in Azure Monitor, you can slice and dice the data. You can apply filters on that particular data. You can create custom dashboards. So if you had an application, let's talk about a fairly small application, one front-end VM and one back-end VM, and you were interested in monitoring the CPU of the front-end VM and memory utilization of back-end VM. You can construct a dashboard that shows just these relevant metrics and monitor the health of your infrastructure. Now, from a networking standpoint, all of our networking services send relevant health information, send relevant operational information into Azure Monitor. So whether you use our connectivity portfolio, which consists of things like ExpressRoute or VPN gateway, or our delivery portfolio, or security portfolio consisting of firewalls or NSGs, we send all the relevant metrics into Azure Monitor. So depending on the component, you should be able to see the utilization for each of those components. You should be able to see the status, health, the operational metrics. And if you wanted to go beyond observability, beyond health, you wanted to troubleshoot, we also have the log-related information for you to troubleshoot. Now, all of this data is good. We also have a number of tools, like I mentioned a few slides earlier. When you have an outage, your highest priority, what is going to be your highest priority? Your priorities at that point are, how do I pinpoint, or how do you pinpoint an issue on your network? How do you localize it to a particular component of the network? And once you have localized the problem to a component, how do you remediate? How do you service heal? Now, given the number of components that we have, the number of tools that we have provided you over the years, for someone coming new into the platform, you have a vast number of choices, and we are trying to simplify the options. But just coming onto Azure, given the vast number, what are some of the challenges that are going to be on your mind? So the first one is, given all the tools, where do I even begin? Do I begin with Azure Monitor? Do I begin somewhere else? Do I begin with other metrics? What path do I take? Of all the rich tools that Azure provides, what troubleshooting tool should I use? And finally, when my NetOps team, when my team tells me that the problem has been fixed, how do I know that the problem has been fixed and not been temporarily suppressed? So over the last several months, we looked at how our component services, our development engineering teams were solving problems for our customers. We also sat in with CSS, our support organization, to see how they were guiding you on localizing problems and fixing them. And we have shadowed some of you on premises at your sites, and you've been kind enough to share your playbooks, your cheat sheets as to how you were debugging, how you were troubleshooting issues in Azure. We took the best practices across our support organization and the information that you provide us and brought them together into a solution that is more contextual, more intuitive, and definitely more actionable for your NetOps teams. We launched this solution as Azure Monitor for Networks at Ignite 2019, late last year. This is a cross-resource, cross-region, cross-subscription network monitoring console. Abhishek here will provide us with an overview of how this solution can help reduce the time to troubleshoot issues on your cloud network.
Thanks, Ajay. So the first question that we have when we start off on any journey is, where do we begin? And for that, we have created something called as Azure Monitor for Networks. Currently, when you deploy any resource in Azure, any networking or any other resource, we create a set of metrics for that particular resource that are available for you. These metrics help you understand the utilization of your resources, the latencies that are involved, and along with that, you can actually trigger alerts on these particular metrics. The second thing that we provide is resource health, which tells you whether the resource is working fine or not. This Azure Monitor for Network aggregates all this information in a single pane and lets you access the resource health as well as the metrics so that you can start your journey and understand if the latencies are going up or the utilization has spiked, or if you're, say, for example, a backend is not responding. Since these metrics are generated by default, you don't need any agent to configure. The other thing is, in this particular view, what we've introduced is a search functionality. Normally, when you go in the portal and search for a particular term, we search through the resource names. But when you're deploying applications, these particular terms, say, for example, if you have deployed an application called HR Web, this could be hosted on an application gateway or a load balancer, and that information exists in the configurations of your particular resource. So the search that we've introduced actually goes and searches through your resource configurations and are able to identify which particular resource has that term. For example, in this case, when I search for HR Web, we were able to identify that an application gateway configuration has HR Web listed. And along with that, there are about 2 virtual networks and 3 public IPs somehow associated to this particular world. The other thing that we've introduced is once you have identified an application gateway, you can also see how you have deployed it. So we give you a visual view of the configurations that are involved. In this case, you can see there's a front-end IP, there are a bunch of rules and listeners and connected to different backend pools. Along with that, you also observe that there are red and green lines. That's when we pre-run diagnostic APIs that the services provide and are able to populate the results so that you can take corrective actions from that point onwards. Now let's take a look at this thing in live in action. So in order to access the view, first you would go to Azure Monitor. In Azure Monitor, you go under Insights and Networks, and that's where you'll be able to access the view. This particular page, there are 3 key segments over here. The first is we've given you the capability to slice and dice the data based on your subscriptions. In this case, I've got 34 selected. We don't have any limit on the number of subscriptions that you can select over here. Then if you want to look at based on a resource group, you can go and select one of the many. I have got 577 over here. And then if you want to target specifically on a particular type of a resource, you can do so by selecting over here. So this gives you a way of focusing your energies on the particular subscription or the resource that you're looking for. The second thing that you see over here is the network health. The second section is network health. Here you can see all your resources along with their resource health. For example, over here, I've got 47 application gateways and all of them are reporting as available. And similarly in load balancers, there is one load balancer which is saying that safety is degraded. If you want to just focus on a particular kind of resource health, you can go and select your numbers from here. You can just filter it out, basically. The third section over here is your alerts. Now for alerts basically is on a metric. For example, you've created an alert and that alert was fired in the last 7 days. Any alerts that were fired would show up over here along with the severities that you have configured. Similarly, if you want to configure new alerts, you can do so right from here. This particular view gives you a way of understanding what all information is provided by Azure by default. Let's take a look at the metrics that we have available for you. So when you click on application gateways, we would go and extract the information for all the healths, the specific alerts that are available for that application gateway, for that particular instance, if they were fired in the last 24 hours, and the metrics corresponding to it. In this case, you would observe that we are showing throughput, response status, fail request, unhealthy host count. However, these are not the only metrics that application gateway supports. There are a lot more. We have just picked 4 for you to give you an idea that what kind of metrics are available. Similarly, if you go and select a different resource, for example, an ExpressRoute circuit, we have selected a different set of values for you, like bits in per second, bits out per second, ARP availability, and BGP availability. This gives you a sense that all the kind of metrics that are available and the actions that you can take on it. If you want to drill down further on any of these metrics, you can do so by clicking on that particular metric. It takes you to the metric view where you can either apply splitting, add filters, or you can add more metrics to understand what's happening in the system. Now going back to the search functionality that we were talking about. So the example is, say for example, you have a payroll application that has been deployed in Azure, and you as an admin receive a complaint from customers saying, oh, payroll is not accessible, and it's the end of the month, people are unable to see their pay stubs. The normal way that you would proceed in this direction would be that you would see where that payroll application is deployed. Right? You might have a cheat sheet which says, okay, it's behind a load balancer or an application gateway, and here is the resource, and things like that. Instead, what you can do right now is you can just go over here and search for payroll. As mentioned earlier, we would go and search through the properties of the resources configured. And in this case, we identified that there's an application gateway that's related to payroll. If you drill down further over here, you would observe that your unhealthy host count is high and so is your failed request. What you can do over here is you can go and click on this application gateway resource, and we will create a dependency view of all your app resources, how this particular application gateway is configured. What we have for you over here is a very simple deployment with just 4 rules. But you might have a scenario where you have more rules and listeners, say 50 or 60 of them. At that point, this particular visualization might get a bit too crowded. What we have done is we have provided you different ways of slicing and dicing the visualization itself. You can either filter out based on a particular listener and a rule combination. If you want to focus on just a particular backend pool, you can do so. And similarly, on the health status that we have identified for each of these backend pools. We have also implemented the search functionality right in over here for you. For example, if I were to just search the word test, we would highlight only those pathways where the word test appears for you. For example, in this case, there's app gateway test rule. And if you look at this particular backend pool where you have app gateway test.azurewebsite.net, and this way you can focus your energies on a particular pathway or a resource right from this view. Now that you have got an idea of what is available by default, now you want to go and further drill down into other investigations. So you identified, there are some issues over here. For that, we have also created a set of troubleshooting tools that are available in Azure right now for you. And Dylan would be talking about those troubleshooting tools. Dylan?
Thanks, Abhishek. Hey, everyone. Today, I'm going to introduce you to some of the troubleshooting capabilities of Network Watcher. Here's a sample network on which we're going to run our troubleshooting scenarios. This is a payroll calculator application that rests in the cloud, as you can see on the calculator VNet. This is used by HR to calculate salaries and other financial information. It serves as a hub of a network and is connected to other spokes. For demo purposes, we are showing just one spoke here, which is the attendance application, which it is connected to. For security purposes, the connection between the calculator VNet and the attendance VNet is peered through a firewall. As you can see on the screen, there are 2 UDRs labeled. These are routing the traffic to an Azure firewall. HR personnel access this application to the corporate HQ, which you can see on my left. So now, let me show you on my screen how this would look in Network Watcher. So this is the same layout now visible in the tool, in the Network Watcher topology tool. As you can see on my right, we have the PayCalc payroll virtual network setup. This is connected to the attendance payroll virtual network through a peering. As mentioned, there are custom route set up here, which direct traffic to a firewall. In this topology, you can also see NSGs, IPs, load balancers, backend pools available in your topology. Now we're going to talk through some troubleshooting scenarios and how we would use Network Watcher to deal with them. The first scenario, as I might suspect, is that suppose I'm facing a connection issue on my application that it is performing in a buggy fashion. How might I debug it? First issue I might observe is there's probably an issue between the connection from my corp HQ to my VPN gateway to the cloud. How might I debug this? For this, we have a tool called VPN Troubleshoot. Let me show you how VPN Troubleshoot works. VPN Troubleshoot allows you to select a set of gateways and or connections and run diagnostics on them. Once these diagnostics are done, not only does VPN Troubleshoot give you the issues, but also decorates the issues and gives you proper action items that you can use. Allowing a moment for my screen to get visible. As you can see on the screen, I have a VPN gateway called Azure Gateway 0. It has connection 01 set up in it. And I might want to select these and click on Start Troubleshooting to run VPN Troubleshoot. When that is clicked, troubleshooting diagnostics would run and errors would be returned. Now, if I run this tool, what might I see? The first example of an error here is that your VPN gateway isn't up and running. Similarly, another error that I might see here, for example, verify that the pre-shared keys are the same on both premises, VPN device, and the Azure VPN gateway. As you can see, this is explicitly telling me not only the error, but what action I should take to remedy it. Let's move on to the next tool. Another possible issue that I might suspect is that the connectivity between my different VNets, say here the calculator VNet and the attendance VNet, might have been blocked due to a change in security policies. How do I make sure that these policies have changed or not? How do I ensure connectivity between the two? For this, I can use IP Flow Verify. Let me show you that live on screen. IP Flow Verify allows you to select any virtual machine as a source and provide the IP address of any destination. Once these are provided, it tells you whether connectivity to that particular destination is permitted or not. The destination can be any remote address FQDN as you specify. For here, I can show you my result. I select, for demo purposes, I select calc01 as my virtual machine. And once that is selected, all the details are auto-populated. I provided the remote address of a VM in the attendance VNet. As you can see here, the access is allowed, and it also tells me which NSG was applicable. I can also use the same tool to verify that connectivity to the internet or other sources is blocked. Let's move on to another scenario. As mentioned earlier, for security reasons, the traffic between the calculator VNet and the attendance VNet was passed using custom routes, known as user-defined rules, through the Azure firewall. Once this firewall is, I might suspect that this firewall is configured incorrectly. How might I verify that this firewall is working correctly and my traffic is being routed through it? For this, I can use NextHop. NextHop is a tool that allows me to select any particular network interface and tells me the next hop for outbound traffic flows. As you can see on my screen, I selected the attendance 01 virtual machine, which is in a spoke, and I want to test connectivity to the hub. So for this, I have already entered the IP address of the hub, which is 52.225.82.185, and I've run a test. When I done this test, as I've already done previously, the result is the next hop is a virtual appliance. A virtual appliance means that the firewall is currently working. It also gives me the route table ID of the route that I've configured. Another scenario that I might suspect why my application is behaving in a buggy fashion is that there is malicious or unknown traffic on my VM. For this, I can use a network watcher tool called packet capture. What does packet capture do? Packet capture basically serves as Wireshark as a service. It allows you, without logging into a VM, start logging all the packets on a VM and later download them for analysis. You can either download them straight from the VM or have them put into a storage account in Azure. Let us see how packet capture works. As you can see on my screen, this is a list of packet captures. If I wanted to start a new capture on a VM, I might go to the Add Packet Capture flow. Here, as you can see, I will go ahead and press the scope of my CM Preview RG and the attendance 01 virtual machine. Here, I've called my packet capture cal capture, and I'll leave the settings as default. So this will ensure that the whole packet is captured, the maximum size per session, and the time limit, which is a maximum of 5 hours. Once I click OK, these captures will then be available for me to download. As you can see on my screen here, the packet capture 10.05.24.76.cap. This is the file available for me to download. I can download this, put this into any traffic analysis tool like Wireshark, measure flows, and finally find the source of any malicious or unwanted traffic. So that is it for debugging on a particular VM. Finally, I might want to run some sort of synthetic test and see whether my connectivity is actually working, what is my packet loss, or whether I can actually look whether the connection is live or not. For that, I have a tool called Connection Troubleshoot. Connection Troubleshoot provides connectivity, latency, hop, packet loss, all in one package. Let me share my screen. As you can see on my screen, I've already selected a virtual machine called calc02, which was in my main application VNet, the calculator VNet. My destination is attendance 01 in my spoke VNet. I've already entered my destination port as 80. Once I run this, synthetic traffic will be generated from the source and sent to the destination. And the tool will give me the results of this test. How many probes failed, whether the connectivity is available, how many hops were there, and more. I've already run the test for you. It tells me that the status is unreachable. It shows me the hops in the middle. And once I click on it, as I click on an error, it also tells me the error that is there. So I can see here the error type is no listed on destination. This becomes a jumping point for further investigation and debugging connectivity issues. With that, a similar example of an extended version of Connection Troubleshoot is what we call Connection Monitor. Connection Troubleshoot works at a point in time. Connection Monitor works on an ongoing basis. You can set up a Connection Monitor just as you did here right now, and it will keep pinging a particular destination on an ongoing basis. To tell you more about Connection Monitor, I shall hand it over to Winnie.
Thank you, Dallin. I will now be talking about how you can monitor network connectivity between any two endpoints in a distributed environment. Going back to the setup that you just saw, picture a distributed environment where applications in the corporate office need to connect to applications hosted in Azure and in other clouds. For example, a typical Contoso on-premise site would need secure and dedicated connectivity to the payroll app, which is hosted in Azure, which might internally need data from compensation, taxes, and other applications. This site may also need connectivity to productivity tools like Outlook, Dynamics, CRM, etc. Now, in such cases, the standard questions that we hear from the infra team are, how do you check reachability to key applications, which may be in Azure, which may be in other clouds, on-premises, etc.? Which solution should I use? Or should I use more than one solution for on-premises and Azure? Is there a single pane of glass for my hybrid setup through which everything can be monitored? And if there are different sources, then how do you correlate data from different sources and stores? And in case of threshold breaches and events, how do we get alerts in real time? For some of these frequently asked questions, we have a new and improved Connection Monitor, which is a one-stop solution for network monitoring in distributed environments. This solution is currently in private preview. Using Connection Monitor 2.0, you can monitor connectivity from your Azure VMs to any endpoint, which may be in cloud, across clouds. You can also monitor connectivity to your other Azure VMs, which are in the same region, different availability set, etc. You can also use the same Connection Monitor to monitor connectivity from your on-premise host to any endpoint across the globe. All your data is stored in Azure Monitor as metrics so that you can get alerted in real time. Data is also stored in log analytics workspaces so that you can write custom queries, build correlations with other data structures. Connection Monitor 2.0 uses the Network Watcher extension for Azure VMs as agent and Azure Monitor agent as agent in the on-premise machine. With Connection Monitor 2.0, you get a unified experience for Azure and hybrid monitoring. Cross-region, cross-workspace connectivity monitoring, you don't need to worry about where your destinations are as long as you have chosen one Connection Monitor. Better visibility into network performance with topology and diagnostic data, fast alerts, and Azure Monitor support. Going back to the Contoso IT example, in Connection Monitor 2.0, what you would do is you would create one Connection Monitor and two test groups, one for each use case. The first one monitoring connectivity to O365, Outlook, whatever, and the second test group monitoring connectivity between your Azure VNets. In turn, tests would be connected, which would test connectivity from on-premise and Azure. Quickly going to switch to the demo now. This is the Connection Monitor dashboard, and you can see the connection monitors that you have created by subscription, region, etc. You can apply filters to focus on selected connection monitor. You can search for a connection monitor that you're looking for. You can switch views from connection monitor to test groups to test. Just filter on loss in latency values, and you will be able to focus on the use cases that you are looking for. Now let's go and investigate one particular connection monitor, the demo network monitoring. If I expand this connection monitor, I can see that there are test groups, attendance to compensation, connectivity to Outlook, one region to another, etc. Now let me further expand these connection monitors, these test groups, and you can see that all the tests that are checking connectivity between VNets, between on-prem and these endpoints are listed here. Now let's take a look at the connectivity to Outlook test group. And here you can see how two different on-premise locations, Win8LGH and WinGTV, connect differently to Outlook.com. Let's click 8LGH over TCP. And now you can see trends of loss in latency for connectivity to Outlook from this particular on-premise location. You can see that there is 0% loss, and if you scroll down, you'll be able to see that the latency is a little choppy. You can even go back in time, set your own custom time to the time in which you saw an event, and you can see what was the lost latency behavior at that particular point in time. Right? You can also click on topology view, and you will be able to see the topology of connectivity from A to B. Now let's take a quick look at the attendance VNet. And if I click on it, I can check connectivity from attendance to a peered VNet of compensation. Let's take a look at it and let's see what the loss in latency looks like. As you can see, the trend lines show up. You can also click on topology, and this topology will be able to show you all the network resources that are in the path and how the connectivity is going from one VNet to the other. As you can see in the examples that we've been discussing about, there is a firewall that has been configured to route the traffic from A to B. Now let's take a look at a case where things are not as good as they seem. So as you can see, connectivity from attendance VNet to calculator VNet is failing. When I click on this particular test, I see that there is 100% loss. Now let me try and figure out how and why I can fix this so that this connectivity can be restored. As soon as I go to topology, I see that the destination seems to be showing some issue. The calc02 VM seems to be showing some issue. I click on it and I can see that this is because there is no listener on the destination, probably some firewall. Local firewall is blocking connectivity, and I would have to fix that to basically enable connectivity between the two. Going back to the dashboard, I'll just take a few quick minutes to show you how easy it is to create your connection monitor. Just click on create and give basic information like your subscription, region, etc. And what you can do is you can use the default workspace that Network Watcher provides to you, or you can also use your own custom centralized workspace and just choose where all your monitoring data needs to go. This can also be the workspace in which data from other log analytics solutions like Service Map, App Insights, etc. is coming in for your monitoring needs. You just choose a workspace. Let's say I choose this one. And next up, go and create your test groups. Really easy to just add sources. Your sources can be basically any VNet, any subnet. You can choose any workspace that you want to send your data to. This can be the default workspace that is created for you by Network Watcher, or you can choose your own, and this can be the workspace where data is coming in from other log analytics solutions like Service Map and Application Insights, etc. Next up, you just go and create your test group, and you can quickly add your Azure VMs and your non-Azure VMs in the same connection monitor across regions, across workspaces. Just select a few. You can next just add destinations. These destinations can be endpoints, Azure VMs, or just plain Office URLs. You can also add your own endpoints like bing.com, etc. Just quickly enter your test configuration, choose your protocol, choose your port, set your thresholds of loss and latency, and you're as good as done. As soon as you click on create, your connection monitor will be created for you. Now, that was all about Connection Monitor 2.0, our latest offering in preview. hear a lot of customers interested in monitoring their ExpressRoute setups. If you want to monitor the health of your ExpressRoute circuit, you can use Azure Monitor metrics like BGP up, down, bits in, out, etc. And you can set alerts on them to know whether your circuit is up or not. To monitor connectivity between your sites via an ExpressRoute setup, NPM has a solution called ExpressRoute Monitor, using which you can know loss, latency, and bandwidth utilization of your circuit and your peerings. ERM has a rich topology that decorates the edges, primary and secondary connection, latency, etc. All the data is stored in Log Analytics workspace, and you can create alerts as well. Now, using ERM, you can see topology from both on-prem to Azure and vice versa from Azure to on-premise. Now, as you can see in the first image, ExpressRoute monitoring depicts hop-by-hop latency and the Microsoft edge, the provider edge, and the circuit visualized in the middle. By knowing the overall latency, you can look for the hop that's contributing to maximum latency and investigate it in detail. You can also see Azure to on-prem topology. ERM detects both primary and secondary connections depending on the routing that has been set up for your traffic. You can see trends for both loss and latency, and just like Connection Monitor 2.0, you can go back in time to the actual event and check the health of your network. ERM also provides ER-specific bandwidth utilization of the circuit and peering over the last 30 minutes. You can also see the bandwidth distribution across VNets for any across hub VNets for any ExpressRoute circuits. Now, if you are an ExpressRoute circuit user, then we strongly recommend that you use ExpressRoute monitoring to set up alerts and to detect connectivity issue in your hybrid setups. Next, I'm going to talk about the network audit solutions that we provide in Azure, starting with NSG Flow Logs. Now, NSG Flow Logs can be recorded for any network security group that is associated at a NIC at a subnet or a VM level. You can configure multiple NSGs from different subscriptions to send incoming and outgoing flow information to one or more storage accounts. Whether traffic is cross-cloud, hybrid, inter-Azure, all the flow information is stored in a 5-tuple format in CSV files in these storage accounts. NSG Flow Log records for each flow, source IP, port, destination IP, destination port, protocol, the rule applied, traffic block, lots of information. Not only does it record flow information, it also records bytes and packet counts per flow. Data is collected in storage account every minute, and if you want fast data, you can build integrations with Power BI, Grafana, etc. to visualize this raw data. Or what you can also do is use traffic analytics and get deeper insights into your flow data. So this build up for the next solution that I'm going to talk about is traffic analytics, which is actually built on top of NSG Flow Logs. Now you can use traffic analytics to get insights into your network flows from public internets to Azure VNets, traffic going through key Azure resources, traffic within Azure, etc. Now, for traffic visibility, you can find out your top talkers, who is talking to whom, your over and underutilized resources, etc. Like I mentioned before, data in bytes and packets is also available along with flow data. You can also get insights on how much traffic was allowed and blocked based on NSG rules, ensuring that your network deployment in Azure stays secure. All the flow data that we get from NSG Flow Logs is decorated with data from Azure Security Center to know how much of the traffic, blocked or allowed, was malicious. You can also correlate this data with IP and country-related information to know where this malicious traffic is actually coming from. You can also analyze your network resources like ER gateways, load balancers, etc., and use actual traffic patterns to understand utilization. For example, a common question that we hear from customers is how much of the backend pool is utilized, and then they scale out accordingly. Now, before I go into the demo, I'm just going to talk about how traffic analytics works. Now, how it works is that it pulls data from the storage account in which the NSG Flow Log data is sent based on the frequency, 60 minutes or 10 minutes, Traffic analytics pulls data from storage account, reduces flows based on source IP, same source IP, port, etc. to a single flow, decorates it with security and Azure-specific context, and pushes it into a log analytics workspace. We also publish a detailed schema document so that you can write custom queries and build deeper insights. You can also correlate data from traffic analytics and drill down to actual flow for forensic purposes. I'm just going to quickly move on to the demo in a second. And this is what the dashboard actually looks like. You can see the total flows that are coming into your network deployment based on all the places where you have enabled NSG flow logs with traffic analytics. You can see total flows, how many were inbound, how many outbound, allowed, blocked, benign, malicious, all of that. You can also see topology related information for your virtual network, subnetworks, Azure regions, etc. You can also see flow data by VM, subnet, VNet. These are your top 20 IPs with maximum traffic flow. This is the Azure information. This is the VNet, the subnet. This is your most talkative pair. This particular VM IP is talking to an unknown VM. This is the IP. You can see data in flows. You can also switch to bytes and packets and get the same data in that context. You can even pivot on different types of data like VNets, etc. You can also see your flow information, not just in flows, but also in bytes and packets. You can also see data related to NSGs, your application ports, other network resources like load balancer, app gateway, etc. Now let's quickly take a look at all the VNets that we have in our deployment. I'm just going to open the topology view for the VNets. Let's take a look at the virtual network topology view. And here are all the virtual networks in your environment where you have configured NSGs to show data to NSG flow logs and to traffic analytics. You can pivot on various sources. This is the attendance payroll VNet that we discussed in our previous examples. Now, let's quickly pivot on who's talking to this particular VNet. And as you can see that this attendance payroll is talking to calculator, not something that is seeing much flows right now. There is also communication to some external public, to some Azure VNets, which have not been enabled with traffic analytics, hence we're not able to resolve them. And there is also some malicious flow coming in. I'm going to click on more details to show you all the other insights that we have with respect to this particular attendance VNet. You can see the time series traffic distribution for this VNet. You can see that these are the malicious IPs that are communicating with this VNet over this protocol or for this port coming in from these regions. These are the top regions that are communicating with this VNet. You can see these are the top protocols over which communication is coming. Now, this is important information because you may have accidentally left a port that you wanted to block unblocked. And in that case, what will happen is that you will be able to spot it from here, and you can then go and alter your NSG to make sure that you are not exposing the port anymore. Right? Going back to the dashboard. Now let's take a look at some of the top ports to see what information does traffic analytics provide on that. As you can see, the top ports that are seeing traffic are port 80, followed by port 8080, followed by 443. Now, for each of these ports, you can see how much TCP traffic came in, which were your top talking pairs. You can see the total flow information. You can also switch to bytes and see data, how much of this was inbound, how much of it was outbound, etc. Clicking on See All. Now, this view will show you the time trends of traffic at the port and all the top protocols. As you can see, all the ports are here selected. These are your top 5 protocols. You can search for any particular one, and the details for it will load here. Let me just search for 443. And the view will change accordingly and give you information specific to whatever was recorded for port 443 in the setup that you have chosen. As you can see, for 443, these were the top IPs that received traffic. These were the top malicious IP, and this was the overall flow information. Now, you can also click on See More, and you will be able to go to the Log Analytics interface so that you can write custom queries to slice and dice the data. That is all that I have for you folks today on network monitoring in Azure. I'm going to pass the control back to Ajay now.
Thank you, Winnie. Given the amount of time, we were only able to share information on a small set of tools. But as you can see from these tools, you now have access to a central health console to start your network monitoring journey. You also have seen tools to debug, troubleshoot service-specific issues. Connection Monitor helped you monitor and get alerts if your applications or networks weren't reachable. Once your network was set up, running, monitored, Traffic Analytics can help you audit your network activity and ensure that your cloud network stays compliant. All of these solutions are available today. We would love to have you try them out and provide feedback. Thank you. I will hand over the call to our moderator, Pamela. Thank you.
Thank you, AJ. Yes, just a quick reminder that all of the resources that were mentioned today are all up on the right-hand corner of your console. I'd like to take a moment and thank all of our speakers, some great